All right. All right, so we returned out here to our forever home, and you can see all of the forms have been stripped from the last time we were out here. We can see our concrete walls, we can see our footing, and you can also see that we have initiated our waterproofing, and in this case, the install of Comfort Board 80. This is a rock wool product. It is actually classified as a stone wool. I know a lot of people in the industry, they love to call it rock wool insulation, but rock wool is the brand or the trade name. Rock wool is not the type of insulation. It's actually a stone wool insulation, just for clarity. So when you're out there talking, if you want to talk like you know what you're talking about, you call it stone wool. It's made from basalt rock. It gets melted or smelted to a almost liquefied consistency, gets whipped around like a taffy machine and gets stranded out into an insulation. In this case here, it is a batt insulation. We're using 2 inches, has an R value of R8. As much of an energy nerd I am with our projects, the R8 really isn't of a whole lot of concern here in this application, and I'll tell you why in a little bit.
Forever Home, a Build Original series, is brought to you by Builders First Source, Baczek Exteriors, Huber Engineered Woods, and Rockwool. Forever Home, a Build Original series.
All right, Build Show. Steve Baczek, architect, out here. We're out here on the Forever Home site. And I want to take a few minutes and talk to you a little bit about one of the products that we're using out here, Rockwool. So there's no organic material in there. This doesn't sustain any type of mold growth, any mildew. Now, one of the beauties of this also, it's in fact fire resistant. Yeah, it can take up to about 1800 degrees Fahrenheit. It's also sound absorbent because of the way the fibers are constructed inside of this, and it is in fact water resistant. Now, I have here a couple pieces of Comfort Board 80. So the Rockwool stone wool product comes in a comfort board, which is a little stiffer, can be used on the outside of the foundation. You can also use it above grade as an exterior. You can use it on the interior of your foundation walls. It also comes in a comfort batt. And the batt, you're going to see us using that here. We're going to use it on all of our interior walls. We're going to be down below grade, using it in our stud cavities. You're going to see the Safe and Sound product. So there's a pretty wide range of what they have available. If you're looking for an insulation that can carry a pretty wide spectrum of materials for your next project, I'd go hit up rockwool.com. You can follow them on Instagram on RockwoolNA and see all the products they have to offer. We use them all around the country, so get with their reps and find out exactly what product you should be using on your next project. We are south of Boston significantly. The beach is literally a quarter of a mile away from here. So there is a lot of sandy soil, and you know, I mean, there's no rocks, there's no gravel. This is, you know, people would pay for this to put it in their kid's sandbox. It's as good a play sand as you can get. But understand, from a building science and a water management perspective, the play sand, or this really granular sand here, it has the ability to drain water very easily. And what that means is that your risk in having water sitting up against the foundation, it's probably, I would argue, almost nil here. And I'm going to show you why in a second. We're going to do a little test here, and we haven't tested the test. So what you're seeing on camera is exactly what is happening and what I'm hoping to happen. But the other thing to understand is we're down in the garage pit here. And I know I explained that, you know, in the earlier video where I talked about why did we excavate, because there was an old house here and we're standing in the old basement of the house, and we would have, You know, we could have brought this up with engineered fill, but the choice was, let's just cast the taller walls and we'll bring this up. So when it comes to risk, right, the best way to eliminate a leak in a project is to not let it see water. So we're in a condition here where we have beach sand, pretty much. Water is gonna go away. We're also at an elevation here. If we went out and went down into the backyard there, you'd understand that we're probably minus 30 feet down at the bottom of the hill from where I'm standing. So what does that mean? It means that when I look at the topography of the site even, which hydrophobically, you'd want to expand it for probably a half a mile to understand what the ground is doing, right? Because a quarter of a mile from here, the ground is probably doing very similar things to what's happening here. But because we're so close and there's not a pond of water at the bottom of the hill, well, that suggests that there's never really any water here, because you can't have water uphill and no pond down here. It would want to find its way down and make the pond in the lower lying areas. So without further ado, we're going to do the risk test. It's very similar to a perk test. For those of you that are familiar with a perk test, when you're doing septic systems, you dig a hole, you pour water in it, you time it. Well, I'm going to take the timing factor out of it. And this is more about just visual risk. So we got a 5-gallon bucket. We filled it up at the neighbor's house. I dug a little pit here. And without further ado, I'm going to test my hypothesis. And we're going to pour the 5 gallons of water into the hole. And we're simply going to watch what happens. And as you can see from where the water line was, that water is literally going down. I'm going to guess that, yeah, in less than a minute, that 5 gallons is going to disappear into the sand below. It's pretty much about half gone right now, right? So without having to sit here and talk all the way to the end of it, I think it's really safe to say that we're in an area of extremely low risk, because we're probably not going to get that level of concentration up against the wall anyway. So we've far exceeded the amount of water that is going to see the wall. So with that low level of risk, then I'm not so much worried about draining the wall as I would, say, in a place where the water table was, say, 3 feet here, right? So the stone wall insulation here by Rockwool, their comfort board, we're using it in a capacity to be a protection board here, not necessarily a drainage board. So I don't want you making comments or writing to me and saying, hey, you used that comfort board 80, it's not a free draining. I understand that, and honestly, I talked with the building science expert at Rockwool, and we discussed it. And I told him, you know, I asked the question, does it drain? And he said, no, it's really not designed to be a drainage mat. It will drain. If you put water on the top, eventually it would make its way down. But you're not putting this up to be a drainage mat. We're putting this up to be a protection mat. In addition to that, we get an R8 energy resistance, thermal resistance from it. Even though we don't go all the way to the top, there is still a little bit of benefit there. You can see down along the bottom of the footing, we have our full waterproofing going in, and it goes up the wall behind the comfort board 80. We have a perimeter drain, and all of this, we're going to jump on the other side of the wall, and we'll talk about that installation. But I really wanted to come here, and here you have it. We've probably been talking less than 2 minutes, and it's a hole that's already starting to dry at the bottom. So again, you know, when you're talking about waterproofing and you're talking about putting protection mat on the side wall, it's really the first thing you have to do with water management is understand your risk, right? You've heard me talk about climate tuning. You've heard Matt and I in building science series talking about you need to know what your annual rainfall is for your area, because you don't necessarily need to build the same water management strategy for a house in Phoenix that you do in Seattle. So it's the same here. I could go 3 or 4 miles from here and be at a property where the water table's 3 foot high and it doesn't drain that easy. Here, we're at a very, very low risk, as we just demonstrated. So that's the basic reason of why we moved to a comfort board on the wall as a protection mat. So I'm gonna jump out of the hole. I'm gonna catch up with you on the other side. We're gonna talk about how all this stuff gets installed. All right, so just helping out my buddy Lucas here, making friends with all the trades. What's up, Lucas? So we're putting up some waterproofing here, and I know that we've already done the full waterproofing and this gets sprayed on. And yeah, it's always, you know, when you're out on a job site, there's always the risk of you putting your hand on something and it actually sticking there. So that's why I do that. But you can see there's not, you know, no risk there. But Lucas just put a couple dabs, and the reason for putting a couple dabs is to give that comfort board some adhesion there to stick to the wall. Now remember, on the other side, we talked about the risk associated with using a comfort board. So if we start down here and look at the foundation wall, right? We look at what's the highest risk at the foundation wall. Well, it's where all of the metal strap connectors that displace the 10-inch wall bleed through the wall. So Lucas went around and he prepped all of those holes before the waterproofing truck comes and sprays the wall. So basically that is the first hit, right? We get that initial waterproofing on the high risk area. Then we come and we do the whole field of the wall here, and you can see it's a little thicker at each of those. And then Lucas is putting those dabs on there and then basically putting the comfort board 80. There's not a whole lot of rocket science to this. You guys know where I'm going with that, right? It's not rocket science, it's building science. One of the other things to understand is, yes, we had torrential downpours last night. That was certainly measured in inches of rain for our area. And so we have a little bit of the dirt that slid down here, but you can see we have stone around the perimeter. There's already been a perforated pipe around the perimeter of the project. We're gonna jump inside the foundation wall and talk a little bit more about that water management sub-slab. All right, so I made my way down into the basement. I know you're probably saying, what's with the narrow concrete hallway there? Well, if you remember when we were forming this up, I talked a little bit about this. This is where the stair comes down from the garage into the basement. So we'll have a stair in there at some point framed once we get the slab. And you can see we have our 3/4 inch stone. Now our footings are 12 inches deep, but notice that the stone only comes up to about 10 inches. So there's literally between the bottom of my foot and the stone, we have about 2 inches of space there. That's totally intentional. You can see right here where the structure's going. We have our beam line here. Columns are probably on the order of about 8 feet or 9 feet apart. I put a little mock-up here together so you can see what's happening here. That first layer of comfort board, it's pretty much flush with the top of the foundation board, right? You can see a nice flush condition there. And then the second piece will get laid on there, go up, and then this is a little short, it's just a scrap I picked, but we'll have this, so this is a full 4 inches, and then they'll pour the slab basically inside of that insulation cradle. And so we'll get full continuity on our thermal control layer to the tune of, where are we at, R8, R16 underneath. We'll have R8 at the wall there. When we go to finish out the finished spaces in the basement, we'll have a 2x4 wall. We'll hold that off the wall 2 inches. And notice we have our 2 inches there. We'll spray this with closed cell. It'll go down and connect to that vertical face, go up the wall into the band joist area, and then we'll get continuity across the slab, up the wall, and up to our subfloor. And then we'll pick up our insulation at our exterior framed walls, which probably a couple episodes away. But you can see here, in an older, say more typical house, you would typically find these footings probably centered on the basement. And that was a basement that maybe didn't have finished space in it. So you can see that here it's offset probably, 2/3 to maybe a third. If you've seen some of my older videos, and I'm going to reiterate it here, we're going to be talking clean basement and dirty basement, right? Dirty basement is, this is kind of the utility hallway in which we service the whole house. This is going to give us the ability to go up and over the beam, and you can see that the beam is going to be lower here because there's a beam pocket, and that's going to suggest that the beam is down below the framing, which means that all of the spaces above the floor joist are going to be open, so our utilities can go up and feed this whole section of house as the floor joists run from the camera to me. So dirty basement, things are allowed to be below the floor joists. Clean basement, as it suggests, the rule is nothing is below the floor joist in the clean basement. So moving around, now we have a 3/4 inch stone here. Like I said, it's all going to get covered in the comfort board, but we also have a 4-inch perforated pipe, and I grabbed a quick space there. I think if you literally look inside, you can see the light coming in. So it is perforated. There are a bunch of slots here. You can see them on the side. And this snakes around the whole perimeter. And we also have the one on the outside, because when I did that hole, digging hole risk thing, the water that we don't know is anything ever going to rise up out of the ground, right? And we're not talking about necessarily next month, next year, or in 5 years. There's the argument that this foundation is not going to be seen again, or these footings aren't going to be seen again for maybe 100 years. So the question is how do we mitigate risk for, say, the next 100, 150 years, right? I'm not going to go the whole 500. I'm going to be relatively conservative on that number. But even at 100 years, we have to plan ahead and make sure that if there is a major water issue down here, that we've attempted to at least solve for it as best we could. Once this concrete slab goes in, we don't have any more opportunities below the slab. So this is our one chance to put something in, put it in right. And you can see we have our sump basin in here. And if I lift this up and take a peek in there, you'll see we have all of our pipes that are coming down in there, interior pipes, exterior pipes. It's bone dry, even though it literally poured last night, and we don't have anything there. Now, chances of us needing to put a sump pump in here, I would say they're probably pretty small, but we have the sump basin. We can put a sump pump in there if we need to, but I don't think we will need to at the moment. But understand, we've put in our mitigation path should we need to. A couple things to look forward to. We've already had Builders First Source out here. They've measured up the full foundation. We have trusses in the making. We have a ready frame package in the cutting stages. All of that stuff is going to be coming out here soon. We're going to turn this over to Mass Green Insulation and Shoreline Builders, Jim and Taylor, of course, managing this project, doing a fine job. We're never going to have to worry about either of those guys. They do their job very, very well. And of course, Mass Green Insulation, they're going to do all the comfort board under here. We're going to pour that slab, and we'll see them a little later when we're talking about insulating these foundation walls and the above grade walls and the attic insulation. So there's a lot in front of us, and I'm really looking forward to sharing it with you. So anyways, I'm Steve Baczek. This is The Build Show. All right, so hopefully you enjoyed what you're seeing out on the job site there. Yeah, very low risk of water. You saw, we did that little 5-gallon bucket test. The water disappeared in, I don't know, less than a minute for sure. So there's never going to be a water problem on this property. We're pretty high up, and the ground is about as good a draining system as you can get. So, you know, as an architect and, you know, as a builder, I would think, we're always weighing decisions on what kind of level of risk are they putting us in and on, right? Are we being in a high risk? Are we going to choose systems that minimize that risk, lower that risk? So, you know, understanding this particular site, understanding the way the water is, I think it's safe to say the sump pump is probably never going to come on or never have a need for a sump pump. It's just going to drain to daylight if the water ever got that high. But I don't think that drain is ever going to get called to action. But anyways, let's talk a little bit about what we're seeing down there. So we'll start over at the footing here, and you can see we have 2 layers of Comfort Board 80 underneath the slab, right? So that's our 16.8 or 8.4 per inch, or per 2 inches. So 4.1 per inch. Yeah, so 16.8, we stop one at the slab, the second one goes up, we turn the corner. We're gonna pick this up with some closed cell spray foam. That's our standard detail. And I know a lot of you are out there saying, well, why are you gonna switch? Why not just run the Comfort Board up? Why not do this? Why not do that? That area, it is probably the most cost-effective decision to just spray the closed cell. It's a hard one to compete with. Like, it always costs more to put up sheet goods in our area with our insulators. So, I mean, most of the insulators will tell us the cost of the rigid board is probably equal to the cost of us just spraying the wall for 2 inches. So we usually go with that. It keeps that high permeable or low perm number so that we keep all the moisture at bay out in the wall. And the reason we can do it here is because we have our 15 mil Stego vapor barrier here. So any moisture that is trying to make its way up, it gets stopped at the Stego. Any moisture that is trying to make its way in the wall here gets stopped at that closed cell. So we have really good vapor control in this foundation wall assembly there. And then of course we can do a wood framed wall on the inside, and then we can fill that with an R15 unfaced rock wool bat to enhance our insulation. So, you know, here you're getting 15, you're getting the 2 there. Let's just say that's worth 12-ish. So that's our 27 below grade, right? And we have 16.8 down here across that assembly, as well as, you know, we have a full 10-inch capillary break with the stone. So, I mean, and this is all in an area that is at extremely low risk. So it's working, the site's working in our favor. We do most of our standard details here, and they have the ability to, you know, basically handle a lot worse condition there. But swapping over here to the inside, you can see there's our interior footing. So we'll bring that 2 inches up to it on the bottom, and then we'll let the top one go over. But understand, our column is going to come all the way down and sit on the footing. So yeah, is there a thermal break here? Yes, but it probably accounts for 0.00005% of the surface area of the house. So guess what? If I'm going to take a penalty, I'll take that one, because inside here where this is 72, this concrete slab is probably at 55. So we're talking a 17-degree delta. Yeah, I'll take those bets any day of the week. So that is that system, basically footing and wall. If we move up the wall a little bit here, and we'll check out this detail. All right, so coming up the wall, there's our foundation wall. And yes, we have 2 inches of comfort board on the outside. Now, I don't know if I can't remember if I stated it in the video out there, but understand, I don't think that comfort board, will it drain water? Eventually, yes. Will it degrade in water? No, it won't. It's a stone wool product, right? It's made of stone that is just kind of whipped and turned into this taffy-like substance, and then turned into a board, spun into a board product. But yes, it's not going to rot. The whole reason for that, for the most part, is to provide adequate protection. And we're using 2 inches under the slab, so we just ordered, more pieces, and then we did the outside. So you saw our insulators, our insulators out there. They were dabbing all of the penetrations where the metal spacers go through the foundation wall, and then they did a 60 mil waterproofing, which we in fact call out somewhere here, I'm sure, 60 mil waterproofing. And then we put the 2 inches of comfort board on the outside, and that's just to protect this against backfilling and over time, right? If we're going to put this waterproofing membrane in, and that waterproofing membrane is, it's going to go up there, right? We want to be able to protect that very well so that it doesn't get damaged, and it just lasts as long as the building does. Now, does that insulation provide some insulative thermal value? It does, but the problem is, and this is the problem I have with exterior insulations in general, it gets short-circuited on that thermal bridge right there, right? If the concrete, I basically push that outside of the building, but if we insulate on the outside and we rely on that, then unless that insulation comes all the way up to the top there, and then it creates a whole bunch of problems. So we just limited it to being our protection board for the system there. And then you can see the closed cell, we're gonna rise that up, take care of that band joist area. And then we have our zip R6 on the outside here. And then of course we have our rock wool, unfaced rock wool bat, R21 there. So we're gonna get that wall to basically R27, and we'll have a really good air tightness there. But anyways, that's the rundown of our insulation package from the foundation up through that band joist area.